Hello everyone, welcome back to Code Enzyme, and in this video we are going to discuss topological sort. Now this is also an important problem for competitive programming. So basically what topological sort is. Let's define what topological sort is actually. So suppose you are given a directed graph, so with some nodes 1, 2, 3, 4. Let's only consider 4 nodes, okay? And suppose if we have only these edges, okay? So what is the DFS of these? We have 1, 2, 3 and 4, okay? Now suppose I add this edge also. So my DFS, so one possibility is obviously 1, 2, 3, 4. There is there is also one more possibility that I go from 1, 2, then 4, and then I visit 3, right? This is also one possibility. And let's say I have some other possibilities, like I have one edge like this, and I also have one edge like this, okay? So if my graph looks something like this, then I have various possibilities for DFS, right? So from these possibilities I want to find such a DFS traversal. So I want to find such DFS traversal where if I have an edge between u and v, okay, then you should, so if I have an edge between u to v, then you should come before v, okay? So like if I have an edge between 1 and 2, so 1 should come before 2, and if I have an edge between 2 and 3, so 2 should come before 3. So clearly this is not a topological sort because 2 is coming after 3, okay? Then if I have edge between 3 and 4, so 3 should come before 4, so this is also not a topological sort. Then if I have edge between 1 and 4, okay, 1 is obviously before 4. Then if I have an edge between 4 and 2, so 2 should also come before 4, so this is also not a topological sort. So we want to find such a permutation such that if I have an edge between u and v, and if I have an edge between u and v, u is coming before v in the DFS traversal, okay? Now where is this helpful? Let's say you are doing some work and you have some task like task 1, task 2 and task 3, task 4 and task 5, and there are some dependencies, like third task is dependent on let's say fourth task is dependent on task 2, so I can't do task 4 if I have not finished doing the task 2. Then there are some dependency, like task 3 is dependent on task 1, so I have to finish my task 1 before doing the task 3, and the rest is something like this, okay? So there are various possibilities. Okay, let's also have some dependencies like this, so I can't do task 3 before doing task 1 and task 2. So there will be various traversals, but clearly if I can do 1, 2 and 4, I think I should do 1 and 2 tasks before because they are dependent. Then I can do 3, 4 and 5. So 1, 2, 3, 4, 5 is obviously one of the possibilities of the topological sort. There can be some more, like I can do 5 first, then I can complete 1, 2, 3 and 4, because 5 is an independent task, so I can complete it anywhere between. So I can do also, this is also a topological sort, this is also a topological sort. We can print any topological sort. Basically we just want to find at least one of the following topological sorts, right? So this is what a definition of topological sort is. Now there are two ways to find topological sort. One is using simple DFS, and the other is something called Kahn's algorithm. Okay, now both are very intuitive, so let's see them one by one. Now what if we have something like this? So task 2 is dependent on task 1, task 3 is dependent on task 2, and task 1 is dependent on task 3. Then we have no topological sort. So I can say topo is only defined for DAGs, directed acyclic graphs, right? Because so otherwise, if there is a cycle, then we have no topological sort possible. Okay, now how do we go about finding these? So there is simple algorithm. One is using DFS. So for DFS, what we can do is like the clearly I am on int node, right? So I have this function. So what DFS algorithm looks like? First I have to set visited of node equals to true, right? Simply, and then I can visit all the nodes for int v in neighbors of node and do my DFS traversal, and after so the do all the DFS stuff, and once this loop is over, then I can say topo dot pushback node. So this is what it looks like if you are doing topological sort using DFS. Now if you are trying to do the same thing using Khan's algorithm, it is KANHS algorithm. I don't know how to pronounce this. So the idea is pretty simple. Let's say you have something like 1, 2, 3. 3 is dependent on this. Let's say 4 is also dependent on this. So idea is pretty simple, that in any directed acyclic graph there will be at least one node whose out degree is 1, whose out degree is 0 and in degree is 0, right? So there will be at least one node, since there are no cycles, so there will be at least one node that will have no out degree, and there will be at least one node that will have no in degree. So like one has no in degrees. Now if there is some node that has no in degrees, it is independent, right? If there is some node that has in degree equals to 0, then that node is pretty much independent. So we can obviously start from those nodes. And what I will do is I will also maintain a reverse graph. So if I maintain a reverse graph, this edges will get reversed. So 1, 2, 3 and 4, and then let's reverse the edges. Right, so this is my reverse graph. Now what I can see in my original graph, the in degree of 1 is 0, so I can start with 1. In this we can't, if I do BFS from here, then there are no children. So what I can do is I can remove these edges. Okay, now the in degree of this node, the 3 and 4 becomes 0. Okay, so I can take any of these. Let's take 3 for now. So these edges are also removed. Okay, now let's go to 3, and from 3 there are again no in degrees that have 0. From 3 I can't go anywhere because this edge was removed. So now I will also remove these. Okay, now the in degree of 2 is still 1, but in degree of 4 is 0. So I will go do a BFS on 4 and on this graph. So clearly from 4 also I can't visit any edges, so I will remove this. Now the in degree of 2 becomes 0, so I will take 2. So one possible topological sort is 1, 3, 4, 2. So that is the idea of Khan's algorithm. Basically you do make a reverse graph and try to do the same thing on this. Let's see the implementation of these two. I think it will become more clear in the code. I will show you both the implementation using Khan's algorithm and DFS. Personally I find DFS one pretty easy, so my main focus will be on the DFS one, but let's see both of them. Okay, for practice I'm going to solve this problem, course schedule. Basically this is from the CSES problem set. So let's first read the problem statement. You have to complete n courses. There are m requirements of the form. Course A has to be completed before course B. Okay, so basically this is a standard topological sort problem, and if there is and it is also not given that we have no cycles in the graph. So if there is a cycle, we want to print impossible. Okay, now let's first make a file. Okay, let's first make a file, and now int n comma m, c in n and m. Let's just make a graph. So graph of n plus 1, and for n range m, we have int u and v, c in u, v, graph of u dot pushback v. I think that's it. And now I want to find a topological sort. Okay, how do I go about it? Let's say first thing I want to make a visited array, because this is a directed graph. It is not easy to find the find if the cycles are there. So either I can maintain two arrays to check if this is in my to check if this is in my current stack or not, or I can simply create a visited array. Okay, so I think I will go with the visited array. And there is also one more, so I will store the final answer in this topo array. Okay, now or I can say simply topo of n plus 1, and let's say my current index is topo of n, and let's say int current index is equals to let's say n minus 1. Okay, you will get why I'm doing this. And let's make a function. So void int, and this is my DFS function, and it is a lambda function. So I'm on currently this node, and first thing first, I'm going to do visited of node equals to 1. So I'm setting that 1 means it is in the stack. Okay, why is this giving me error? Okay, node, yeah. So first thing I am setting is that visited of node equals to 1. So once 1 means it is in my stack, and 2 will mean that it is completely visited. Okay, now I will traverse in all of the neighbors of this node. So for int child, or you can say neighbors in graph of node, if visited of child equals 1, then I detected a cycle in this graph, so topological sort will not exist. So I can simply print impossible and exit my code here. Otherwise I can say if not visited of I, visited of child. So if my child was not visited, then I can simply say DFS of child, right? And in the end I will say visited of node equals to 2, and topo of I and index minus minus equals to node. Yeah, so I think this will work. Let's say for I in range 0 to n, cout topo of I with a space. So this is using DFS algorithm. Oh, I forgot to call my DFS function. So DFS of 1, and we are still getting wrong answers. Why is that? Because we have visited of n plus 1. Currently they all will be 0. And okay, I only did it for this. Now I have to say for I am 1 to n, if not visited I, then DFS of I, right? Now I think this should work. So we are getting this. I think this is correct. Now let's try to submit this and see if it is working. So let's select course schedule and submit. So we got so our solution got accepted. Now this is using DFS. Now there is also something called Khan's algorithm, and the basic idea is you first take the I think I will just try to implement the Khan's algorithm also, but it is not simple as this. What you need to do is you need to also make something called a reverse graph. So let's name it R reverse, and I will also have an array for in degree. Okay, now what I can do is I will say in degree of the in degree of v plus plus, so I'm increasing, and I can say reverse graph of v dot pushback u, right? Now once this is done, I think I don't need visited array. Maybe I need it, maybe I don't. Let's see. Now I need to traverse in this whole graph and check if the end degree is 0. So for I1, and I also need a Q, right, because this is DFS algorithm. So Q and let's say Q, if end degree of I equals 0, then Q dot push back, Q dot push I. Okay. Now while not Q dot empty, okay. Now while Q is not empty, then I need to pop the first element. So U is equals to Q dot front and Q dot pop, obviously. So first thing that I am going to do is I'm going to traverse in my graph, and for all the so I want to remove the edges, right? So for all the neighbors in of U, I will first decrease the end degrees. So for int child in graph of U, I'm going to say end degree of child minus minus. So I'm decreasing the end degree of every child of this node, every neighbor of this node. Then I also need to check one more thing. If the end degree was 0, then I can consider this for the next iteration, right? So I can say if end degree of child equals 0, then I'm going to push this into the queue. So Q dot push child. Okay. So we have this. I think I don't even need the reverse graph because the end degree is decreasing, and basically I can say topo of INDX minus minus equals to U, and for I1 C out, I think for I0 C out topo of I with a space. But there is one more thing, wait a second, 2 5, so 2 is, there's no dependencies on 2 and 5. I think this is in reverse order, so I have to print everything in reverse order. So I will say n minus 1 I is greater than equals to 0 and I minus minus. Yeah, or maybe I can do is I can start the index from 0 and maybe do index plus plus here instead, so I don't have to do it in reverse order. I think this will go till n, not n minus 1, and I think this should pass the test case. So basically it was this algorithm is called Khan's algorithm, and in this case this is a special one. I don't even need the reverse graph, I think. Yeah, let's try to submit this and see if it gives us a correct answer. Or actually there is one more thing, like before doing this I need to check if the current topological sort is correct or not. So for that I want to I think this will become really complex now. So checking if the topological sort is valid, I have to first get the indexes of every node that are coming in this topological sort. So first I want to store that, and I can do that using this code. Like first I will make a vector of index plus 1 and then topo of I equals to I, like that. So I'm storing the every index of every node in this in this thing, and now for every edge in my graph I have to check if this is valid. So basically for I in range 1 to n, and for in child in graph, and if the indexes are reversed, then I have to print an impossible here. So that is the code, and now let's try to see if this is working. Yeah, and let's try to submit this. Okay, so our solution got accepted, but it was kind of slower than the previous one, obviously, because we have to check, we are checking here after forming the topological sort. So that is a bit slow, but it will still pass your test cases. Yeah, so that was the Khan's algorithm, and I hope you were able to understand this. If you were able to understand this, kindly like this video, subscribe to the channel. I will see you guys next time. Thank you.